What is up? What is up? What's going on, guys? Welcome back to one of my favorite desserts there is. Jellied moose nose. Yeah, thanks Canada. So today we're going to be talking about service orchestrations. So when we decompose our applications into microservices, we have to consider how they will work together. Sometimes a single action performed by a client will need to work across several services to complete that action. Consider the checkout process. Theaters have limited spaces, right? So when a user purchases a ticket, their seat needs to be reserved. If the show is sold out, then the user should not be able to purchase any tickets for that show. So before a user can purchase a ticket, they need to make sure that the show has seats available. That functionality is found in the show service. If there are seats, then they need to check out and purchase a ticket with the checkout process, correct? So once the ticket is purchased, the show service will then need to be updated. It will need to reserve the seats for a customer for a specific show. Sometimes we actually place this orchestration requirement on the client itself. This means that in front-end applications or mobile applications or admin portals, they need to know how to work with each service and make sure they are checking the shows for seats before proceeding to the checkout on their own. But if we want to be nice to our clients, we should provide a single checkout process that can be evoked and handle the orchestration details on the back end. So one possible solution is API orchestration. Let me pull that up, get rid of this. API, there we go. So this means that we would provide a single API that can be used to interact with all of the clients and orchestrate the microservices that are required to perform an action. So in this example, any client can simply send a checkout request to the API, and the API will handle the details with the checkout and show service. Another orchestration technique is to incorporate a messaging layer. Let's do that. Let's get rid of this and get rid of that. This is our messaging layer. You can think of a messaging layer as being like a back door to your service. Customers come in through the front door, the API, and the goods that are purchased from other businesses are delivered in the back door. A message layer is typically a TCP application that can be used to communicate with other microservices. So in this example, customers can check out with the checkout service, and the checkout service will update the action on the messaging layer, which will in turn reserve the seats for the show. The details of checking the show service for available seats and reserving them are all handled on the back end via a middleware to middleware communication. Sometimes a microservice might briefly go down or become unavailable. So let's do that right here. We got our red X. So let's say the shows are completely like it's broken down. We cannot use it. Something happened. Okay. So consider this situation where a customer wants to purchase tickets, but the seats cannot be reserved because the show service is down. Well, instead of stopping the transaction, checkout service could sell the tickets and reserve the seats when the show service becomes available. Your messaging layer could queue up the reservations, and when the show's service becomes available, you can operate on the message queue or queue. I say queue, but some people say queue. I have no idea, man. I say queue a lot. So queue and reserve all of the seats that needed to be reserved while the service was down. So it'll do this. We'll have a queue with reserved tickets, and then once the show service has been repaired, meaning no more X, that means that everything is A-OK. Let me move this down. A-OK, and we're gonna start going through the queue, and since reserved tickets is in there, it'll start reserving tickets. So the techniques that I just mentioned are just a couple of techniques that are available to you when it's time to orchestrate your microservices. So in the next, when I get out of this, let me get out of it. We're actually going to go through that with our ticket system JS, or the application we built in the last video. So There we go. So now let's actually take a look at our API orchestration layer. So to orchestrate the process of making a reservation, so far we have two separate microservices, right? We created in the last video, which is Reservation.js and Show.js. So in the show service, we know that in order to make a reservation, we have to make sure that the show has available seats, and then we need to end a put request to this service to hold those seats. So if sorry about that. I was thinking about something else. We also need to interact with the reservation service, all right? So the reservation service itself saves the name on each reservation as well as their count of tickets. So if I look at this reservation service, reservations are being made through a post request. So by sending a post request to the home route, we are actually making the reservation. We don't have any information within this function about the show service because, well, we don't really need that inside the reservation service, right? All it needs to make a reservation is a show ID. So we're going to create a third application. This application is going to be an API orchestration layer, and we actually already got that started, which is right here. So this is a foundation for an Express API. We're just going to make some changes to this file to make it work. So if we scroll to the top of the file, let's see what's going on, all right? We have the packages that we're going to need to use. That includes Express, Body Parser, Course, Node Fetch. The next couple of lines are little helper functions that we can use to send the HTTP request to either the show or reservation service. On line 6, we have a get all shows function. It will send an HTTP request to localhost 3001 where the show service is running and give us a list of shows. On line 10, we can also get an individual show by invoking the get show function and sending an ID. It will send an HTTP request to 3001 and use the ID to select the individual show for that service. We're also going to need to be able to hold seats. So again, using localhost 3001, the show service, we're going to send a put request using fetch, and we'll send the show ID and the count along with the put request to hold the seats for the show service. And then finally, we're going to need to make a reservation. Making a reservation entails sending a post request to localhost 3002 this time, where the reservation service is running, and sending it the name, count, and show ID. So this is a completely separate service now, and this API will actually orchestrate making a reservation with multiple services. So within this API, the first thing we need to do is scroll all the way to the bottom right here. So one benefit of an orchestration API is security. We can only expose the parts of the underlying services that we want clients to consume. The ticket orchestration API only returns a list of shows. The registration list is private. Everyone can look up the shows and the number of tickets that are remaining on each show, but we only want administrators handling reservation information. So this API only needs to expose the shows, not the reservation. So I'm gonna, in line 77 right here, that's exactly what we're going to do. So first of all, I'm just going to do a simple count to log, and right here I'm just say requesting shows from show service, and then we're going to create a variable shows, and we're going to set that equal to await get all shows. I always say shows. So remember that get all shows returns a promise. So I'm using the async and await in order to wait for that promise to resolve to the shows. And then I'm going to go ahead and respond with some JSON, just the list of shows. So down here, res.json. And we're going to just pass in shows. And that is it. Now we need to orchestrate the reservations. When a consumer makes a reservation, we need to first look up the show and see if there are seats available. If there are seats available, we need to hold those seats with the show service and make an official reservation with the reservation service. So up here on line 36, when we send a post request to our API with reserve, we are invoking this function, okay? So we're going to make sure that you sent a count in the request body and a name for the reservation. But before we can decide whether there's a show, we have to look it up. So we're going to look that up using the show service. So down here in 51, line 51, right here, we're going to grab the count of how many you've made. So this is a count you passed in as a like you want 3 tickets or 5 tickets. That's what we're trying to get. So parse int, we're going to do a parse int just to make sure it's actually going to be an integer. Parse int, and then we're going to get rec dot body dot count. And then down here, let me actually space this out. Down here, we're going to look up the show. So we're going to be using, I'm going to just create a variable right now, show. Now remember, we already created these variables right here, so you don't have to do that. Show is going to equal a weight, and then get show, which is up here. Get show where we need the ID. So get show where we're gonna pass the ID, and that lives inside rec dot body dot show ID. On line 56, we're basically just saying that, hey, if we don't have the show, we couldn't find the show with the show ID you sent us. So we're gonna go ahead and stop making a reservation here and return an error. But on line 61, if we do have a show, we're gonna take the house size and subtract the number of tickets that are currently reserved, and that should give us the remaining seats. So if we have seats available on 63, we're checking the remaining seats to see if it's less than the count of tickets that we want to reserve. If it's not, we're gonna let our users know that it's an error, that they can't reserve because it over exceeds the number of tickets that we are the seats that we have. Now that we have that in place, we're going to need to orchestrate the other 2 services. We need to hold the seats with the show service. So I'm going to go ahead and log that down here. Console.log, and right here we're just going to say, I'm gonna use the template string or template syntax, string syntax, holding, and I'm gonna say the count, the number of tickets. It's a $, count seats for. And then we're going to do the $sign again. And we're going to grab the name for the person that we want it. And that lives inside rec.body.name. And then down here, we're actually going to await for our hold seats to hold seats. And we do need to pass in the ID and the account. And that is it. So the ID we already have right here. Copy this, and we need to pass in the count. Show ID right there. Now we need to make our reservation. So I'm gonna let the user know that, hey, we're getting started on reserving this stuff. So console.log. I'm gonna use the template syntax again. We're going to say making the reservation for, and then give out the person's name. And then give out the person's name. for rec dot. Sorry, body dot count. Dude, I need to get better. I'm pretty sure everybody's like, God damn, this guy needs to get better on typing. I do. I really do. And right here, we're actually going to be sending out the reservations, or storing the reservations being sent to the where's our little helper function right here, make reservation. And we're going to just be storing that in a variable. So const, I'm going to name mine reservation, is going to equal to await make reservation. Actually, I'm going to copy this just in case I misspelled it or something. Where is it at? Right here, copy. Which I didn't, but. And right here, we do need to pass in three things: the name, the count, and the show ID. So rec.body.name right here, and then the count, and then the show ID. And that is it. Now it's actually time to actually test this API to see if it works or not. So for this, I actually need to open up my git bash because Windows doesn't, or I haven't pre-configured my Windows or my desktop to actually run curl commands. So I'm gonna pause the video for a second and get that running. So I have my bash running, but the first thing we need to do is actually start our services. So we're gonna do pm2, and we're gonna create 2 instances of every service that we have. So show, reservation, and API. So start reservation. I need to get inside that folder. So dot cd inside of that folder, orchestration. There we go. And now we're gonna do pm2 start reservation. I'm gonna do -i because I want two instances of that. Grab that, come back here. Now let's do shows. Give me 2 instances of that. And now let me get what's the other one called? API. Now we have 6 instances, 2 for each service that we have. So let's actually test this out. Now that we have that up, I need to get my git bash. So the first thing I'm going to do is actually get a list of all available shows and information on tickets available. So for that, we're going to have to send a curl request to localhost 3000. Remember, 3000 because API is running everything now. It's running all of our things from 3001 and 3002. Remember that. Look at this. 3001, 3002, right? So that's why we're doing 3000. So our curl, we're going to do send that request to http localhost 3000, and we should get our, yeah, we do. Let me actually make this, let me actually clear this and do it one more time. Clear. All right, now we do get an array bag with all of our shows and all the reserved seats for that show, or for a show. So for Yodeling concert, which this has this ID, we're gonna have a house size of 100, and we have only 18 reserved. Shakespeare play 50, 10 reserved, and then our other one, which is Food Poison Rally, which is fully booked. Now what we want to do is actually test out our reservation, or reservation route. So we're gonna reserve some tickets. So I'm actually going to reserve some tickets for our Shakespeare play, which has this ID. So I'm gonna copy this ID. Now to send a reservation post request to reserve, we need 3 things: the name, the count, and the show ID. Okay, just to let you know. So I'm come on, don't do this to me. Okay, I gotta actually write it out. Why am I not? I can't even. There we go. All right, /3000/reserve. And we're gonna do X -X, and we want to do a post request, post request, and then -D to send in some parameters. The 3 parameters is name was one of them. Let's do Wonka for our name, and then count. We're gonna do 10, and then show ID. We're gonna set that equal to the one we just copied, so I'm just paste it right in there. And that is it. Now let's actually see if we make this reservation. It does not look good. I don't know what went wrong. Well, nothing really went wrong. It was just taking forever to actually run this request. I have no idea why. I'm still trying to figure it out. But it actually went through. As you can see, I did it twice, by the way. As you can see, the first time we had 10. And then I did do it twice. Even though we got this error, it actually ran through. Now I have reserved 30. Once I run the curl HTTP localhost 3000 to grab everything, I get reserved 30 for this Shakespeare play, which is correct. So I didn't even figure out what's going on, but nonetheless, it actually worked. So this is actually an example of how we can use another service, an API orchestration layer, to orchestrate complex events that traverse multiple microservices. Even though this is a pretty crappy, not really crappy, I wouldn't say crappy. I'm the one doing it. That's why I'm so biased on this. But it's not. I think it was a great example. It's just this part right here. It just, I don't know, something went wrong, but it ran it. So, anyways, I hope you enjoyed the video. This is actually the very last video for this what is it? This, playlist. This playlist for scalable node applications. This is the last one. We already scaled through the X, the Y, and the Z. So I hope you learned a lot from this series. Watch my other videos like Node.js or React. And yeah, guys, thank you so much for watching this series. It's been a pleasure making it for you. And I'll see you in the next videos. The next series of videos, I hope. Anyways, I'll see you soon. Thanks. Bye.